Hi, in this video I'll be updating you on the status of my project on the Hubway data. If you recall, I'm doing two things with the data. I'm doing data analytics to find the commute trends, and also I'm doing the simulation of the data. For this video I'm only focusing on the data analytics, and for the future video I'll be covering the simulation in more details.
The first part in our data analytics journey was to download the data from the Hubway website. The data downloaded was for the 2016 trips, consisting of 1.2 million bike trips. It's made of 12 CSV files, one for each month of the year. To ease processing the data, we merge all 12 files into one file. The merged file is around 250 megabytes in size, having all 1.2 million trip entries. The following technologies were used in this part of the project to do the data analytics: D3 to read the CSV file and convert it into an array of objects, JavaScript to reduce the data, k-nearest neighbor to classify the days based on trip counts per hour, HTML to develop the user interface to display the results based on user input, and finally D3 to plot the average results from k-nearest neighbors, which represents the annual commute behavior of the riders. The layered architecture diagram for the code looks like this. First, the data layer is responsible for reading the CSV raw files and reducing it to a single file. Ultimately, we reduced the 1.2 million trip entries into 365 entries only, each representing a day of the year. Next, our reduction algorithm uses a double-nested dictionary counter mechanism to count the number of trips per hour per day of the year. Second, the logic layer takes the reduced data and applies the KNN algorithm to it. The goal was to classify the data into two clusters, one for weekdays and another for weekends. Once we have the two clusters of classified data, we average each cluster to produce the annual average commute behavior needed for the plotting. Third and finally, the presentation layer provides an HTML interface that produces the annual commute behavior 2D plots depending on user input. For layers 1 and 2, everything is pretty much my code, while for layer 3, the HTML interface is my code, plus I use some code template from D3 to produce the basic plot structure, which I ended up customizing as well. Next, we show a demo of what the code is doing and a sample plot produced demonstrating one of the commute trends. A typical bike trip entry looks something like this, which contains info like the duration, start and end times, and the source and target destination of the trip, along with their GPS coordinates. Our reduction mechanism reduces the 1.2 million trip entries into 365 entries grouped by each day of the year. To illustrate this method of data reduction, let's pick a sample day from the data like October 26. Looking at the raw data for that single day, it had more than 4,000 trip entries, which are logged by the minute and look something like this. Applying our reduction method, we reduce those 4,000 plus entries into a single entry like this, which shows the total number of trips per hour for that day. This data format is now suitable to be used with the KNN algorithm. Next, KNN is applied to the reduced data by providing it with simple training data of hourly trip counts from a weekday entry and a weekend entry. This successfully produced for us two clusters of data, one for weekdays and one for weekends. We next average the results of both clusters. And finally, we plot the average cluster results using D3 to show the annual commute behavior of the Hubway riders for weekdays and weekends. Here we show our HTML user interface and an example of one of the plots produced, reflecting the annual commute trends of a weekday for Hubway subscribed users. We can clearly see from the plot that the bike commuters do follow the typical commute trend you would expect to see in a more traditional method of commuting like cars or public transportation. On weekdays, we see a peak hour around 8 a.m. where people are going to work or school with around 380 bike trips taking place, and similarly another peak hour around 5 p.m. with around 400 bike trips taking place when people are heading back to their homes after work or school. As for risk updates, so far we did encounter our first risk we expected, which was the raw data being too large to load in memory in the browser. It took more than 10 seconds to load the data in the browser, through which it was actually hanging. To mitigate this, we reduced the data on disk using the reduction method explained previously, and as a result we can plot the final preprocessed data fast on the browser. Another risk we were expecting is that the machine learning algorithms might fail in clustering or classifying the data. We initially tried the k-means algorithm, which didn't do a good job in clustering the days as weekdays and weekends. However, fortunately, the KNN algorithm did a good job in classifying the days. For the next steps, we will be focusing on the simulation part of the project. This will involve setting up the multi-layered map box structure and geospatially laying the bike stations over the map. After that, we will be working on extracting the data needed to do the simulation and performing the actual simulation using D3, which we will be covering in more details in our next video.